All right, so what we've got here is we've got a graph. You guys have already told me. Down here we've got time, and over here we've got elevation. You guys told me elevation means what? How high something is. Usually when you think of elevation, you hear it like on a mountain or a plane. If you're riding in a plane, they'll say we have reached 3,000 feet elevation. I don't know, something like that. Okay, so usually elevation is at bigger numbers than this, but this means height, and across here we've got time. And what I wanted you guys to do was to come up with a story. It says, can you describe what the person might have been doing? Okay, so this involves some imagination. So just to kind of give you a little idea, if this is a person, this person is going up and all of a sudden they reach a height of 10 feet. And then for a second, what do you think this means right here? Their height isn't changing. Okay, so, well, he's not moving at all. His height is not moving. Time is passing. Basically, we are going from 3 seconds to 4 seconds, but he's not going anywhere. And then he goes up a little bit longer, and then again, his height doesn't change, so he stays where he's at for a little while. And then here, his height is going down very fast. He's going from, how high up is he at this point? 15 feet. His height is at 15 feet, and then all of a sudden it drops really fast, almost to 0. And then for a second, nothing changes, and then he slowly, see how this one's going down a little slowly, or more slowly than this section? Slowly, he reaches back to the ground right here at 0 feet. So does anybody have a little bit of a made up story that you could tell me? All right, go ahead.
Skydiving.
Skydiving. So,
That he wasn't moving, he could have been out of the rest station, resting his legs and climbing up that peak of the mountain.
okay, so skydiving would start out in a plane or something, right? So you'd no. So tell me a little bit more about what's happening right here. He's at the ground, and then he does what?
You can either jump out of a plane or you can climb up a mountain, jump off the side of the mountain.
Okay, so your situation is not just skydiving, it's the whole bit. So he's climbing up a mountain, he rests, keeps climbing, reaches the top, rests for a second, maybe gathers his nerve, and then jumps. Okay, jumps really fast. Down here, don't really know what happens here, probably would hit the ground, but something happens. Parachute slows him down, there you go, makes it to the bottom. I like that story. The only thing I see wrong with it is 15 feet. Most people probably aren't skydiving from 15 feet, but it's a good idea. As far as the situation, it matches. You have anything? You have something different? All right, tell me what you got. Climbing a tree. Okay, so he starts on the ground, climbs the tree a little ways, and then he stops, takes a break, goes higher, climbs a few more branches. He gets a cat. Okay, he saves a cat up here. That's why he's doing this. All right. He falls, or the cat falls? They both do? Okay, they fall out of the tree. The cat hits the ground, they hit the ground, and then they roll for a second, maybe. Okay. Anybody else got anything? All right, mate.
He's climbing a mountain.
Climbing a mountain, but this is a pretty short mountain, right? Most mountains are taller than 15 feet.
Yeah.
Maybe a hill.
Yeah, it's a little small mountain.
Okay, a little small. He's rests.
At that point, obviously, the cat is resting for a second. He climbs back up.
Okay.
He dives down face first.
Yes, for sure.
The rock artist.
Yeah. Okay. Okay.
I would do that.
Here's what my thoughts are. Because this is only 15 feet, I like the tree because trees would maybe be about 15 feet. My thought is he's at a swimming pool. Okay? This isn't going to work. Okay, he's at a swimming pool. He climbs up to the diving board. He gets to the first little platform. He thinks, all right, I'm going to jump off here. And then he changes his mind, goes a little higher, goes to the highest platform, takes a break for just a second. Notice, this is seconds down here. This is all happening. This whole story happens in 10, well, this doesn't say seconds. It just says time. This could be 10 minutes. This could be 10 hours. This could be whatever we want it to be. I'm going to say seconds. Okay, so he gets up here. He finally gets to the top platform at 15 feet. He takes a break for about a second, holds his breath, jumps off. At this point, I don't know why he doesn't hit the bottom, but maybe he hits something, and then, I don't know. He hits the water and then floats down to the bottom. I don't know, something like that. Okay.
Okay, at that point, he did a belly flop.
Did a belly flop. So for a second, he just paused. This is really what stung. He hits the water, and then he keeps on going. I like that. That'll work. Okay, so what you guys have realized, what we're going to talk about right now is graphing relationships. I sometimes call this situations. Now, you never really know what a graph is talking about, especially a line graph like this. If they don't give you a whole lot of detail, this could be anything happening here. Okay, I want you to know that this could be anything happening here. The main things is whoever is increasing in their height, and then their height stays at 10 feet for a little while, and then they increase some more, and then their height stays at 15 feet for a while, and then they decrease very fast. Okay, so this could be anything. All right, this really could be just about anything. All right, so let's look at example 1 down here. Here's my situation. Now I'm going to try to pick a graph over here that matches this situation. Each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. A gust, okay, so think of that. A gust of wind, that bam, that happens and a bunch of leaves blow off. And then eventually there are no more leaves on the tree. Choose the graph that best represents the situation. So let's think about this. Over here on each one of these graphs, we've got the leaves. Okay, how many leaves does a tree start out with? Normally quite a few, right? And then eventually we're going to blow off all the leaves. And then down here, this is just time. Okay, so notice in this situation, we start out with a certain number of leaves. What's happening here? All of a sudden there are more leaves on the tree. Does that fit with this situation? No. So I can go ahead and cancel this one out. We are never increasing the amount of leaves. That's what's happening in this graph. We're not ever putting leaves on the tree. In this situation, it's losing leaves. So it's got to be B or C. All right, so let's think about this. You think it's B? So in graph B, let's think what happens. It says each day several leaves blow from or fall from a tree. That's what's happening here. And then one day a gust of wind. When that happens, the leaves are going to be falling off really fast, right? Well, what does really fast look like? It's going down pretty fast. Well, I would say that could be what's happening right here. Really fast. This is when our gust of wind happens. And then the gust stops, but the leaves continue to fall. It's just not happening as fast. So I would go graph B works. Let's see if graph C works. We're losing leaves. And then what happens here? Are we losing any leaves? This means the amount of leaves is staying the same. That never happens in this situation. It says it loses leaves, and then it loses a lot of leaves, and then it still loses leaves. So this situation, or this graph, doesn't work. It's got to be graph B. Does that make sense? It's got to be graph B. The problem with graph C is right here, we're not losing any leaves, and that is not what happens here. All right, let's look at example 2. If this doesn't make sense to you, hopefully it will come with more practice. You just kind of have to be able to follow a graph. The air temperature increased steadily. Okay, that's my first key. Increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Those are all my keys. And then we want to choose the graph. All right, so what do we think? I hear a C. Okay, so let's just match C. Increased steadily, that would be what's happening here. Remained constant, that's what this is. At the end of the day, it increased slightly, okay, and then dropped sharply. Yeah, I can go with graph C. I can go with graph C for sure. We could look at these other ones and see. The problem with graph A is that at the beginning it's constant, and that is not what happens here. What about graph B? The problem with graph B is it's supposed to start out increasing steadily, and that's not what's happening here. So you're right. Neither of those. Y'all are good. It's graph C. Pretty smart. All right. Examples 1 and 2 above, well, on the last page, those are called continuous graphs because they are made by connected lines and or curves. What does the word continuous mean?
It repeats, like it never stops.
It doesn't stop. Okay, it's just something that keeps on going. So that's pretty obvious. These graphs right here, there's never a break. It all just keeps on going. Some graphs are just distinct points, like this down here. And those are actually called discrete graphs. Okay, so what we're looking at is 2 different kinds of graphs. Continuous means they literally don't stop. Discrete graphs mean they are just a bunch of points. So if you look at example 3 down here, that is called a discrete graph. Let's see what's happening here. First of all, they gave us a title, so that kind of clues us in. This is about theme park attendance. Over here, we've got the number of people, and then down here, we're looking at years. Okay, so can you kind of figure out what's happening in this graph? Over the years, what's happening overall in this situation at this theme park? Over the years, what's happening? They're losing business. Something's happening. I don't know if it's just at first, the very first year that they're open, a lot of people show up. And then the next year, not as many people show up. So think about when a business opens, a lot of times at the very beginning, they do really good. And then if they don't have something that's great attracting people, they slowly start losing business. So that's what's happening here. This theme park's doing great. Each year, their business is slowly declining. So let's put that over here. Theme park attendance is decreasing each year. That's what's happening. Eventually, we're not going to put this on here, but eventually, if this pattern continues, they're not going to have any people and probably going to have to shut down. But this is pretty obvious. Every year, they are losing people pretty much. Some years, they lose more than previous years. Okay, so now I want you to look at these two graphs here. I've got a continuous graph here and a discrete graph here. This discrete one's kind of weird. I want you to think for a second. I want you to write a possible situation. It doesn't have to be anything more than just a sentence. What's happening here? Now notice, this just says speed. It doesn't say speed of what. This could be a car, this could be a person, this could be a bike, whatever. Speed and time. And then over here we're looking at pizzas bought versus number of students. Okay, so I want you to think for a second, see if you can tell me a situation that maybe goes with both of those. All right, do y'all have any ideas? I know this one was probably pretty tricky, but do y'all have any ideas for this one? What could possibly be happening? It can be a simple... Decreases all the way to what?
But how do you decrease after it's already started?
All right, so basically what's happening here is the start of this story doesn't start, let's say it's a car. This story doesn't start at 0 miles per hour. This starts at however fast they're going, okay? So they slow down. Here, they're still going at a constant speed. They're not going 0. Speed means like they're going, okay? So let's say right here, I'm just going to make up some numbers. They're going 50 miles per hour. They slow down to 40. Then they stay at that speed for a long time. And then they eventually slow down all the way to how fast? 0, okay? So this could be, they reach the speed limit, okay? So they're going 75 up here, then they slow down because they see a speed limit sign, and then they slow down and they go to the new speed limit, and then they keep slowing down and they reached wherever they were going. They stopped. Okay, so this could be anything, all right? But that's the general idea. For this situation, all right, let's think. This is tough without numbers, okay? We could assume this is counting by ones if we wanted to. I'm going to put little numbers. 1, 2, 3, 4, 5, 6, 7, 8. This could be counting by ones. Over here, pizzas bought. So think about right here versus right here. Right here, they've bought a certain number of pizzas. Here, they've bought more pizzas. Does that make sense? Here, they've bought a certain number of pizzas. And then up here, they bought more pizzas. Okay, so maybe this could be 1 pizza, and then this could be 2 pizzas. So basically what's happening is while there's not very many students, they're only going to buy 1 pizza. If there's 4 students, they can feed them with 1 pizza. But then if there's 5, 6, 7, or 8 students, they probably better go ahead and buy 2 pizzas. Does that make sense? This may not be what this graph is talking about, but this is kind of a tricky one. For however many students this is, they're only going to buy this number of pizzas. If the number of students increases, they're going to have to increase their pizzas. That's what this means. Does that make sense? That's kind of tricky. That's kind of tricky. Most graphs don't really look like that. All right, 2 more things I want to do. I want to sketch our own graphs for the situations that we've got here. So, for example 6, we've got a truck driver enters a street drives at a constant speed, stops at a light, and then continues. First of all, is this going to be points or lines? Is this going to be continuous or discrete? Lines, right? If you're talking about driving, you're not just randomly stopping and starting and stop. Excuse me. So this is going to be lines. So let's think about this. Down here, what should go down here? We're talking about speed and time. Time almost always goes on bottom. So time goes down here, and then over here we're going to put speed. So this is going to actually probably be similar to this graph. So it says a driver enters a street. So the story starts with the driver driving a certain speed. And then he drives at a constant speed, and then he stops. What happens when he stops? What is his speed going to be? 0 miles per hour. Let's think about that, okay? On here, where is 0 at? The very bottom, okay? So at some point, he's going to reach the very bottom here. And then he continues. So let's think about this. He enters a street. They don't tell us what speed he enters at, but let's say he just enters right here. All right, so he enters a street. When you turn into a street, what does your speed do? When you're entering the street, I would say it decreases. You usually have to slow down because you probably turned or something. But then as soon as you get into the street, I would say it probably increases. Probably. Okay, so we're going to say this guy enters the street. He speeds up a little bit. And then he drives at a constant speed. At a constant speed means what does our graph need to do? Right now we're speeding up. Constant means straight flat. Okay, here's my constant speed. All right, constant speed. And then he stops at a light. So what do we need to do here? Go down. How far do we go down? All the way to 0. So boom, we stop at a light. We hit them brakes hard. That's what's happening here. This is a really fast decline. That's okay. And then he continues. So after the light turns green, what are you probably going to do? Speed up, accelerate, right? So we're going to probably, and then boom, that's the end of our story. Okay?
I still don't know what he exactly driving. He would be driving an 8-wheeler and hauling the trailer behind it for that.
Okay. We don't know a lot of things. We don't know if he, like right here, this really looks like he slammed on his brakes. That may not have happened. He might have slowed down much slower than that. I don't know. Right here, this boy punched the gas pedal, sped off. He may not have gone that fast. We don't know a lot of this, but this works. This works. All right, example 7. A small bookstore sold between 5 and 8 books each day for 7 days. All right, think about this. We are measuring the number of books sold each day for 7 days. So, books sold and days. Which one needs to go on bottom? Days needs to go on bottom. Usually time goes on bottom. Days would be an amount of time, right? Or a measurement of time. Let's put days down here. And then over here, we're going to put our books sold. Now, they specifically give us some numbers here, so let's use this. They sold between 5 and 8 books, so I'm going to go over here and I'm going to count to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? If they give you numbers, you should use those because that makes your life easier. They also said this is happening for 7 days, so I can count to at least 7 down here. Day 1, 2, 3, 4, 5, 6, 7. This helps. Now I want you to think about this. Do you think this is going to be a continuous graph like this one, or do you think it's going to be specific points? Why is it going to be specific points? You're right.
Because it's not variable.
Yeah. Can I sell 5 books? Exactly 5 books? Yeah. Can I sell 5.5 books? No. Can I sell 7.5 books? No. So when you're talking about something that can only happen in whole numbers, it has to be specific points. All right, so it says a small bookstore sold between 5 and 8 books for each day for 7 days. So we're going to go each day, and we're going to pick a number between 5 and 8, and it can be anything we want. So on day 1, how many books do you think they sold?
2.
Well, I heard 6 first. It cannot be 2. Why can it not be 2?
Two is not between five.
They said they sold between 5 and 8 each day. So I'll take 6. 6 works.
Uh-huh.
All right, on day 2, how many books do you think they sold? Doesn't matter.
So every day they sold.
Somewhere between 5 and 8. So we'll say they only sold 5 books on day 2. All right, how about day 3? 7. All right, that's what I heard first. 7. How about day 4?
No.
8.
8. All right, 8 works. Between 5 and 8 each day. We can't dip below 5. We can't go above 8. How about day 5?
5.
All right, another 5-day book. Day 6. How many books you think?
7.
All right, he's giving us all the numbers, but that's fine with me. And then day 7, what do you think?
8.
Yeah, I'll let her give us one. There you go. So the whole graph, the whole situation here is every day we're staying between 5 and 8 books sold. This right here, that would be a discrete graph. Now, guys, you could have put your points anywhere as long as they're somewhere in this area. You could have done 8 every single day if that's what you thought that they did. Okay, let's do a worksheet involving this sort of stuff. So on today's worksheet, I want you to see what we've got here for number 1 is kind of similar to the warm-up on the notes. But I want you to notice, we're talking about elevation over here, and we're talking about time again. But what happens here? Right here, my elevation is at 0, so that would be like ground level, right? Think of this whole line as ground level. Up here, whoever this is, they get up to 5 feet. And then here, they drop below ground level. That can happen several ways.
On the ocean.
Okay, maybe the ocean. Maybe a swimming pool. But if it's an in-ground swimming pool, if you jump into the water, you're going to go below ground level, right? So any sort of water situation will work. Maybe you go into the basement. Is the basement below ground level?
Yeah.
So anything down here is happening below ground level. And then how do they end up? They go back up and then boom, they finish on ground level. So whatever you want to come up with, okay, just be creative. Write me a little story over here what happens. Now, and I want full sentences. I want you to say, okay, so so-and-so climbed up, blah, 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 blah. And then for here, I want a sentence for what happens here. And then tell me what happens to make them go below ground level and so forth, okay? Don't leave anything out. Yes?
I was wondering, so like, how we have almost like someone's comment. Can we put a name?
You can put a person. You can make this as specific as you want the story if you want to. You can make it you. All right, the rest of this should be pretty self-explanatory. On the back, you're writing a situation for each graph. This can just be a sentence because these are pretty basic graphs. But for this first one, I want a few sentences telling me what's happening here. All right, go ahead. I'm going to say this needs to be at least 5 sentences.